Hey you guys, I want you to meet my friend Pablo. Pablo knows a little bit of karate. The other night, he was almost stolen from his zoo cage, but because he knows a little karate, he could save himself. He actually gave his assailant a bloody nose. Thing is, that blood dripped, and there happened to be some paper on the ground in Pablo's cage, and the blood dripped down and landed on that piece of paper. The cool thing is, we can actually do some stuff to the blood now. We can measure the diameter across the blood drops, and because the blood drops would get bigger the further up the bloody nose was, we can kind of figure out the height of the person that tried to attack Pablo. There were some surveillance cameras at the site of the crime scene, but we couldn't get a really good look at the assailants, and Pablo couldn't see him very well either. But the surveillance camera did show that we have Peggy the panda, Sammy the squirrel, and Rodney the raccoon that were out loose that night and looking kind of suspicious. And as you can tell, conveniently, they all have different heights. So whoever Pablo gave the bloody nose to, we should be able to figure out which one of those characters was in his cage if it was in fact one of them. Now, as you can look up here, what you're going to end up doing is you're going to drop blood from various heights, and then you're going to use that to make a graph, and then you're going to show how the heights affect the blood splatter diameter, and you can then compare it to the samples held at the police station to see who tried to take Pablo. Here's the front page of the lab, and we just went over this stuff with you in sort of the introductory slides, but it might be worth reading that again if you were absent. And again, here's our three suspects, and we're going to try to figure out which of those three suspects tried to take Pablo based on the size of the blood splatter that was in his cage. So on this page, you're going to see what is called the abstract here. In this abstract, you can identify both the manipulated and the responding variable in the experiment. If you read through that, you'll see that the drop of blood from various heights, or the height of the blood drop, rather, would be the manipulated variable. And then you would also see that the splash diameter here would be the responding variable. And you, of course, know how to write a research question if you know the two variables, and you can come up with your own hypothesis for what you think would happen to the splash of the water, or the splash of the blood. It's just red food coloring with water, as the height increased, and then why you think that. And these are the heights you're going to drop the water from using a pipette. So this picture actually shows students measuring blood drops from different heights. Let me see if I can give you an idea a little bit of what they did. So basically what students did is they used a pipette, and that pipette was filled with red food coloring water, which simulates blood. Okay, and then they had some paper down here, and they dropped just a drop of water from various heights. Say, well, your first height was 1 centimeter, but let's say 5 centimeters and 10 centimeters and 20 centimeters and 30 centimeters and 40 centimeters and all the different heights above the paper, all the way up to 200 centimeters. And when they splashed on the paper as it fell down from the various heights, it splattered here, and then students measured the diameter, or the distance across that splattered water drop. And that's what you can see students doing over here. They're measuring the different splatter drops. And I'll zoom that back in over here, and you can see they're collecting that data here. So they did that for a bunch of different heights, again all the way up to 200 centimeters. And then right here, this is where students collected their data. So you would have your manipulated variable and your responding variable, just like you've been taught to set up in class. So this would be the drop height right here, drop height, and this would be the splash diameter. I asked you to have space for 4 or 5 trials plus an average that you could then graph. And the next slide is going to show a sample of student data. So right here you're going to see a sample of student data, and this basically can be downloaded online if you weren't here for any of the lab. A couple quick clarification points: a few of these decimals didn't appear very good, so make sure that this isn't 15 for example, that's 1.5 right there. So make sure that those make sense as you're going through it. This person did 4 trials, so if you're using this data you would add up your 4 trials, 1, 2, 3, 4, push equals, and then divide by 4 to get your averages. You do that down your paper. So this was done from heights of 1 centimeter all the way to 200 centimeters like we talked about previously. And once you have your averages, right here you have to graph that. And I'll get to this over here in a minute, but first you have to graph it. So we'll move over here. Oops. And I'm not going to actually graph it for you, but let me show you what a graph might actually look like of the information. So you may end up with, for example, data points that look something similar to this. You're actually going to find that the splash height does not keep increasing. We're going to talk about why that is a little later in the year. But you actually end up with a best fit line that looks something like this for the data you collected. And maybe it would be helpful if we labeled the axis a little bit for you. Of course, you know the manipulated variable goes down here, and that was the drop height, right? Drop height. And over here would be the splash diameter. And let's go back over here to show you this over here real quick. So that's all the data collected in the lab, but you still need to examine the crime scene. So here's the crime scene here, and you can see that these different diameters were collected: 1.8 centimeters, another splash at 1.8, another splash at 1.8, this one's 1.6, and this one's 1.5. So those were all collected at the crime scene and came from the height of the person that was trying to steal Pablo. So what you would just want to do is you're going to want to put those in your chart somehow, and you could put those, this makeup data had a spot for the crime scene data they just added right here at the bottom of their original data table. So those numbers would just go right in here. It doesn't matter the order really. And there were 5 of them, so you would average those 5 and put it here, for example. And I believe, just off the top of my head, looking at those probably averaged to 1.7 centimeters for a splash size. So then what you'd want to do is you're going to actually use your graph and your best fit line to figure out their height. So what you would do is you would look at the splash diameter and you would find 1.7 over here, because that's what we just calculated at the crime scene. Physically, and you might even write crime over here because this happened at the crime scene. Draw your line over here. You could do a dotted line or a solid line. I'll switch colors. Draw your line over here. Usually you put an X here. You don't want to mistake it for a data point. You might write prediction here so it's obvious you're using your best fit line to make your prediction. And you would draw your line straight down here, and you would just read whatever number this is on your chart, and that would be what you think the height of the person is that tried to take Pablo. And once you have that height, you can compare it to the original page on your lab that has the different heights of those characters. And then finally, you just got to write up your conclusion. A couple comments about your conclusion. Zoom in just a little bit, make it a little easier to see. This is supposed to read like a paragraph if you see this here. I started your sentence here for you. Okay, so you're just going to finish that. My original research question was, you'd find that information on the front, second page of your lab, I believe. And your original hypothesis was, you'd state it here. There is a typo right here, at least on this year's. Hopefully I fix it by next year. You can see that this does or does not, and you would circle either does or does not. The circle one was supposed to be over here. Support my hypothesis because, and then the because is answered by number 4. Okay, so you would answer the rate and trend of your graph. For example, as the drop height increases, what happened to the splash diameter? And then you would give some data points from your data table. For example, when the splash height was blank, blank, and blank, the diameter of the splash was blank, blank, and blank respectively. And then 3 sources of error, and then who do you think committed the crime? And again, try to write in your best paragraph form, basically assuming that my questions aren't even there when you write your answers. And that basically concludes the podcast for this, or screencast for this rather. So I hope you have enough to get your lab done at home if you weren't able to make it in class. Thanks.